So, you've got this brilliant AI idea, but you don't exactly have access to a supercomputer, right? You're not alone. For years, some of the most groundbreaking research has been totally bottlenecked by the need for massive budgets and huge server farms. Well, today, we are tearing down that wall. We're going to build a practical blueprint that shows you exactly how these new, incredibly efficient AI models can turn your ambitious idea into a funded reality using not much more than a powerful laptop.
Right, that's the big question, isn't it? How do you take a concept that you know could change everything and get the actual resources to build it? It has always been a major challenge, but the game is changing, and it's changing fast. And it's all thanks to a new generation of powerful open-source AI models that you can actually run, fine-tune, and deploy on your own hardware. Seriously, the barrier to entry has never, ever been lower.
And this has always been the fundamental problem. On one side, you have these huge ambitions to solve massive problems with AI, and on the other, you have the reality of limited compute power and just fierce competition for every single grant dollar out there. This gap has kept so many amazing ideas stuck on the whiteboard. But what if we could finally bridge it?
Well, that's exactly what's happening. Right now, in 2026, the entire landscape has been reshaped by a new kind of AI that puts efficiency first, without sacrificing power. So forget waiting around for server time. Let's look at two of the most important tools in this new toolkit that are making all of this possible.
Okay, on one hand, we've got Google's Gemma 3N. I like to call this one the Edge Implementer. It is built from the ground up to put top-tier AI onto everyday devices. And on the other hand, we have Meta's Tribe V2, which is this fascinating brain explorer. It gives researchers a simulation of human brain activity like we've never seen before. Two totally different tools, right? But both of them unlock powerful, and I mean powerful, new ways to get your research funded.
Let's dive into Gemini 3N first. Now, this isn't just some big model that they shrunk down. No, it was designed from day one for the intense constraints of local hardware. We're talking laptops and phones, and this right here is the absolute key. This is what unlocks research that doesn't need to be tied to a data center.
So how does Gemini 3N actually pull this off? This is where it gets really cool. First, it uses an architecture called Matformer. The best way to think of this is like a set of Russian Matryoshka nesting dolls. You train one big, powerful model, but it automatically contains smaller, fully functional models inside it. This gives you unbelievable flexibility. Then, for vision, it uses MobileNet V5, an encoder that is so fast it can analyze video at 60 frames per second on your device. And finally, a super clever technique called per-layer embeddings, or PLE, lets the model shift parts of its work from that expensive VRAM over to your computer's regular RAM, which massively shrinks its memory footprint.
And this number just says it all. The most capable version of Gemma 3N can run using only about 3 GB of RAM. I mean, that's less memory than a lot of web browsers use just to check email. This is the game changer. It means you can build projects that were totally impossible for smaller labs until now. We're talking real-time sign language translation on a phone, an app that helps visually impaired people navigate a room, even equipment in the field that can identify invasive plants from a video feed, all without needing an internet connection.
Okay, let's switch gears and look at our second tool, Meta's Tribe V2. So if Gemma 3N is all about putting AI into the real world, Tribe V2 is about exploring our inner world. Honestly, the best analogy for it is a flight simulator, but for neuroscience. It gives researchers this powerful, predictive model of the human brain, which lets them run virtual experiments and test out hypotheses without ever having to book time on a multi-million-dollar fMRI machine.
So how does this brain simulator actually work? Well, it's a brilliant 3-step process. First, it doesn't even try to learn vision or language from scratch. It's smart. It just piggybacks on top of existing, super powerful models. Think of Llama 3.2 as its language center, and VGPay-2 is its visual cortex. It uses them as its eyes and ears. Second, a transformer module takes all that sensory info and fuses it together, figuring out how sight and sound relate to each other over time. And then finally, a prediction block maps that whole integrated understanding onto a super detailed 70,000 voxel grid of the human brain, predicting which areas are going to light up in response to what it's seeing and hearing.
And the crucial takeaway here is just the incredible level of detail. Tribe V2 gives us a 70 times increase in spatial resolution compared to older systems. That's like going from a blurry county-wide weather map to a high-res satellite image that can track a single storm cloud. That leap in detail opens up completely new avenues of research into how our brain regions work together to process the world around us.
Okay, so we've got two unbelievably powerful and accessible new tools. Now comes the most important part.
how do we actually use them to build projects that funders are going to be excited about? Let's walk through two very different, but very fundable, case studies that put these models into action.
All right, case study A. This one is aimed directly at those high-value federal grants, especially the ones in national security and defense. The core idea isn't just to pitch a piece of software, it's to pitch a resilient multimodal actor. That language is key. You're proposing an AI that can see, reason, and act on its own, on a device out in the field, completely disconnected from the cloud.
So here's the architecture for that. We're going to use Gemma 3N's top-tier variant for its unmatched on-device video reasoning. But the secret sauce is implementing on-device retrieval augmented generation, or RAG. This gives the AI its own local library, a little brain extension it can check for information, so it can do complex analysis without any internet at all. This offline capability, it's a non-negotiable requirement for secure government work, which makes this whole package a perfect fit for funders like the Department of Defense.
Now, our second case study takes a totally different route, but it's just as compelling. This project is tailor-made for educational and scientific funders, like the National Science Foundation. The big idea here is to use a unique, super high-quality 2.9 terabyte dataset. It's basically a pristine archive of the internet from 2007 to 2023, including all of Stack Overflow and a bunch of highly moderated subreddits.
So what do we do with this amazing 7 trillion token dataset? We use it to train a brand new, highly efficient 3 billion parameter model. But here's the winning pitch for the grant proposal: democratizing foundation model training. See, you're not just building another model, you're creating a public research tool. You're preserving a vital piece of our digital history. And you're making cutting-edge AI training accessible to academics everywhere. This is exactly the kind of high-impact, community-focused project that the NSF absolutely loves to fund.
All right, so we've got two killer project ideas. But where do we actually send the proposals? Understanding the funding landscape and what each type of funder really cares about is just as important as the idea itself.
You can kind of think of the grant world in tiers. Yeah, at the top, you've got the massive federal programs. But for a lot of researchers, the secret is to start smaller, closer to home. Most universities offer what are called institutional seed grants. These are smaller pots of money designed specifically to help you build a prototype and get some early data. This makes your idea way less risky, which in turn makes you a much stronger candidate when you go for that big federal money later on. They're a crucial stepping stone.
And here's the best part. The funders literally tell you what they want. This is a direct quote from a real $237 million DoD grant program. They are explicitly asking for resilient and autonomous capabilities. Does that sound familiar? It should. It's a perfect mirror of the language we used in case study A. Success in grant writing is all about listening to their needs and then showing them how your project is the perfect solution.
Let's just make this crystal clear. A big federal grant like the DoD RAPID program is looking for a deployable, mission-ready product. An institutional grant, on the other hand, might offer something like $50,000, not for a final product, but to help you build that compelling proof of concept you need to go win the huge federal award. You use one to win the other. It's a strategy.
Okay, we have the tech, we have the project ideas, and we have our funding targets. So let's put it all together into a final actionable blueprint for writing that winning proposal, focusing specifically on that high-value federal track we talked about.
Here are 4 keys to nail that federal grant. 1. Be specific. Say you're using the E4B variant of Gemma 3N. It's the sweet spot for performance. 2. On-device RAG is your killer feature. That offline capability is a huge selling point for security-focused grants. 3. If your tech is already pretty solid, aim for direct-to-phase 2 small business grants. This lets you skip the smaller first step and go right for those $1 million-plus awards. And 4. Connect your work to national policy. Citing documents like America's AI Action Plan shows the funders that you don't just understand the tech, you understand its strategic importance to the country.
And that really brings us to the final thought here. The entire paradigm has shifted. We have moved from an era of cloud-based chatbots to an era of action-oriented AI that literally lives on our devices. The tools for doing truly groundbreaking, fundable research have never been more accessible. So the only question left to ask is, what impossible idea are you going to bring to life?